Hello everyone. This is the phase 2 proof of concept demonstration for Credixa, our specialized BNPL architecture for the education sector. I had like to start with our high level design. As you can see, we have implemented a strict microservices architecture isolated within a Docker private network. The core service in the center, we have our Node.js API gateway. This acts as the orchestrator for all client requests. The intelligence on the right, we have a specialized Python risk engine. We have decoupled this from the core service to handle heavy compute tasks like parsing complex financial JSON structures without blocking the main thread. Uh, the data layer at the bottom, we can see uh, PostgreSQL for our transactional ledger, enforcing strict ACID compliance. For performance, to the left, you can see Redis. This caching layer is critical for our non-functional requirement of sub 50 millisecond response times for repeat users. Note that while the diagram shows a React client, for this backend POC, we are using an automated regression test suite to rigorously validate the API logic directly. A key challenge in phase 2 was simulating India stack and Sahmati APIs without access to live banking licenses. To ensure our simulation matches reality, we focused on two principles: latency parity and data structure parity. Instead of hard coding simple logic, we built a file based mock data layer. Inside our mock data folder, we have JSON files that replicates the exact nested schema of a real account aggregator response, including metadata, identity profiles, and nested transactions array. So here it is. Okay, in our server.js, we enforce uh, enforce a 3.5 second artificial delay. This mimics the real world latency of fetching 6 months of bank statements, forcing our system to handle asynchronous operations correctly. We verify users based on distinct personas. PAN ending in A loads a salaried profile, while a PAN ending with F loads a gambler profile. This proves our risk engine is data driven and handles diverse financial scenarios. Let me run the application. So, Docker compose. Now let's see the system in action. I am running our automated regression suite to validate the end-to-end flow. So okay, so the test case one for Rahul Kumar, which is the happy path scenario. Notice the 3.5 second pause, that is our API simulation kicking in. So the result is approved and the score is 810. The risk engine passed his salary and education transactions and rewarded his financial stability. So you can see all the details here. Now moving to the next test. Test case 2 of Vikram Singh. Vikram has a high income, but his JSON profile contains um, hidden transaction to Dream 11 and Pokerbazi. Okay. Okay, you can see. So the result rejected with a score of uh, 350. The Python service successfully drilled down into the nested JSON, detected the gambling category flags, and applied a strictly penalty. So the third case, Anandya Gupta. She is irregular income but good balance. She is a gig worker. So the result approved. Uh, this validates our engine's ability to support the gig economy, a key differentiator for Credixa. It recognized her high average balance despite the lack of a standard salary tag. And you can see there is another test for Arjun Reddy, who is really the scenario is very low average balance, like a very low transaction. You can see, so transaction amount is very low, so he got rejected and the score is 500. Beyond the business logic, we validated our non-functional requirements. If you look at the latency logs for like a repeated request, the time drops from 3.5 seconds down to just around 9 milliseconds, 8 milliseconds, 28 milliseconds, and 7 milliseconds. This confirms our Redis caching layer is active and successfully bypassing the slow mock fetch layer, meeting our 50 millisecond target. So in the final test, okay, let me show you. In our final test, we attempt to route a loan to a fake institution ID. Okay, you can see. Okay, let's run. Okay. Now the result is the database threw a 500 internal server error due to a foreign key violation. This proves that our PostgreSQL schema physically prevents funds from leaking to unverified account. In summary, phase 2 is complete. We have successfully demonstrated functional microservices backend, a context aware risk engine that passes real world financial JSON structures, high performance via Redis caching, and a bank grade security via database constraints. The system is now fully dev ready for phase 3 integration. Thank you.